Welcome to the Deep Dive. Today we've got a pretty substantial technical package to get into. We have some very detailed source material here. It's a technical analysis laying out the architecture and the whole philosophy behind the on and passive ecosystem. And this vision, it's attributed directly to Ashmui Farr.
That's right. And this is a deep dive with a pretty clear mission, really. We want to distill that core technical vision, cut through some of the buzzwords and really understand the foundational structure they're talking about. The sources, they present this not just as like a bunch of products, but as a superstructure of innovation. That's the term they use. Built for huge global scale, for complexity.
Yeah.
And it seems to rest on these 10 key pillars that are supposed to define its technological brilliance.
10 pillars. Okay, that's quite a framework. But what really jumps out, even before we get into the pillars, is the overall context.
Yeah.
The philosophy that keeps coming up in the documents. It suggests a really radical shift in how we interact with tech. We're talking about moving beyond that common frustration, right? Where you, the user, are always chasing the next update, learning complex new interfaces or, struggling with getting different tools to actually work together.
Exactly. The guiding principle, the one they keep mentioning in the materials, is don't make users chase technology. Let technology understand the users. And that idea, it seems to shape everything, from the AI integration, which they actually call the living brain of the system,
Wow.
to the security, which they describe as bulletproof, and the automation features built into things like O-Connect, O-Shop, O-Tracker, O-Wallet. It's all framed as this one unified, intelligent design.
So the big claim we really need to dig into is this. It's not just a collection of separate tools, but a cohesive, living architecture of intelligence. That's a bold statement.
It really is.
If that's the claim, then we absolutely have to spend time looking closely at the technical foundations that supposedly give it that level of seamless adaptive power. So where should we start? Maybe with the absolute baseline. Speed and resilience.
Yeah.
You can't have global dominance without that.
Agreed. I mean, all the fancy features, the AI, the automation, security, they don't mean much if the system just buckles under pressure, right?
Exactly.
So pillar one, speed.
Right, and the sources, they make an interesting distinction here. They say speed isn't just about, page load times.
Yeah.
The claim is it's about how fast possibilities open, which sounds, it suggests something more proactive, doesn't it? Like an engine that anticipates, not just reacts.
It absolutely does. And a claim like that, it demands some serious next-gen infrastructure. The sources, they insist on achieving zero-lag performance, that's the phrase, even when handling, massive global traffic simultaneously.
Okay, hold on. Zero lag. That's a huge technical claim. I mean, every system struggles under peak load, right? Think Black Friday sales, major streaming events. Something always gives.
That's a fair point. A very fair challenge.
Does the source material give us specifics, like actual technical mechanisms or benchmarks to back that up? Or is it just marketing hype?
They anticipate that skepticism, it seems. The documentation points to 3 critical mechanisms that they say fundamentally change how latency works in their system. The first one is edge computing.
Edge computing, okay.
This is really key because it changes where the data processing actually happens.
Could you maybe break that down a bit? What's the difference between traditional cloud processing and this edge computing in this specific context?
Sure, think of traditional cloud computing like sending a letter across the country to a central library every single time you need a piece of information. There's always going to be that delay, right?
Right, the travel time.
Exactly. Edge computing, on the other hand, sets up these mini libraries or data processing centers as physically close to you, the user, as possible. So let's say you're in Jakarta. Your data processing isn't waiting on a server farm somewhere in, Dublin.
Yeah.
By bringing that computation closer to where the request originates, they claim they can dramatically cut down latency. Kill that perceived delay, essentially.
That would make a huge difference to the user experience, making interactions feel instant, not laggy. Okay, so that addresses the where. What about the how many? How does the system supposedly handle millions of people doing complex things all at once, like processing a payment in O-Shop while they're on an O-Connect video call without everything grinding to a halt?
Right, that's the volume challenge. And that brings us to the second mechanism, parallel processing algorithms.
Parallel processing.
Yeah, traditional systems, they often process tasks sequentially, like a single checkout line. If one person has a complicated order, everyone behind them waits. Parallel processing is described as the engine designed to break down these massive complex tasks into smaller, more manageable chunks. and then it handles them concurrently across multiple processors all at the same time.
So it's like opening up dozens of checkout lines simultaneously.
Exactly. It ensures that all those concurrent actions across O-Connect, O-Shop, O-Wallet, whatever, are all managed at the same time without creating bottlenecks that slow the whole system down.
Okay. And the third mechanism you mentioned, it ties back into that intelligence factor, anticipating what users need.
Correct. That's the AI-powered caching. The system isn't just sitting there waiting for you to ask for something. The AI engine is constantly monitoring behavior patterns, both globally and for individual users. It uses this learning to figure out what data is likely to be needed next, what it thinks you or millions of others will ask for. And then it preloads or pre-caches that data, making sure it's ready to deploy in milliseconds. So the system's performance isn't just reactive, it's designed to be actively anticipatory. That's why the sources use that analogy, the experience feels like stepping onto a digital highway.
Okay, so speed is addressed. But like we said, speed doesn't mean much if the highway collapses during rush hour.
Precisely.
Which leads us perfectly into Pillar 5. Cloud infrastructure, always connected, always scalable. The resilience part.
This is the backbone. This is what supposedly sustains that speed. The sources are clear. This system is built on a custom hybrid cloud. It's not like they're just renting space on AWS or Azure. It's a bespoke architecture designed from the ground up specifically to scale instantly with user demand.
Why is that custom build so important?
Because it's meant to mitigate that huge industry challenge where rapid growth actually destabilizes the platform. They built it anticipating massive, sudden influxes of users.
Okay, so how does this custom architecture actually manage that resilience? What stops it from having those traffic crashes or the downtime that plagues so many other big platforms during, say, a major product launch or event?
Well, it relies on several layers, according to the documents. First, there's dynamic load balancing. And this isn't just basic traffic routing. It's described as intelligent resource distribution.
Intelligent how?
It proactively measures and predicts where the processing workload might spike based on real-time activity and historical data. And it spreads that load across the network before any single part of the system gets overwhelmed. It's basically predicting and preventing bottlenecks before they even form.
So it's like a proactive traffic controller for data. Got it. And what happens if the workload suddenly, say, triples? Like a huge O-Connect event kicks off. How does the system just absorb that massive instant increase?
That's where the second mechanism comes in, auto-scaling containers. This sounds pretty essential.
Auto-scaling containers.
Yeah. Instead of running on fixed server capacity, which is the old way, the applications themselves are housed in these virtualized containers. And these containers can automatically expand or contract based on real-time user volume.
Oh, okay.
So if 10 million new users suddenly log in for a major event, the system components, the containers holding O-Connect, for instance, they just scale up instantly to meet that demand. This is supposed to neutralize those concerns about capacity crashes or downtime that you get with traditional fixed infrastructure.
And data integrity.
Yeah.
What if a whole data center has a problem, like a power outage? How do you ensure global access isn't disrupted and data isn't lost?
That's covered by the use of distributed storage networks. It's about eliminating that single point of failure, which is fundamental in modern system design.
Right.
Your data, my data, it isn't just sitting in one physical location. It's mirrored, replicated across multiple global nodes, multiple data centers. So if one center goes offline for whatever reason, the data is instantly and transparently accessible from another node. The user wouldn't even know a failover happened. The implication here, the big takeaway, is pretty clear. The claim is this architecture was engineered from day one for the concept of infinite growth and nonstop 24/7 operation.
All right, so we've covered the muscle, the speed, and resilience. Now let's pivot to the system's brain power. This is where it gets really interesting. Pillar 2, artificial intelligence integration. They call it the smart heartbeat.
Yeah, and this is where that core philosophy we mentioned earlier, let technology understand the users, really starts to, well, supposedly manifest itself.
So the claim isn't just that there's some AI involved.
No, not at all. If the claims hold up, the AI isn't just, a feature or a chatbot tacked on. It's positioned as the foundational operating system itself. The system's living brain, as they put it.
A living brain.
Okay. Its job is described as continuously allowing the entire ecosystem to learn, grow, and adapt around your unique habits and needs as a user. Instead of forcing you to conform to rigid software rules, the software conforms to you.
Okay, that sounds great in theory. Let's dig into the specific functions that supposedly give it this superpower. Starting with predictive behavior engines. How does it actually map user patterns? What's the mechanism?
It apparently relies on deep machine learning models. The system is constantly passively observing user interactions. We're talking not just clicks and purchases, but timing between actions, common navigation paths, how often you use different products together.
So really granular data.
Very granular. By mapping these comprehensive patterns over time, the AI can start to anticipate your likely next actions, your preferences, even how you might want information organized.
And how would that actually look to the user?
Well, it might manifest as, say, suggesting a smart notification at exactly the right moment you'd likely need it. Or maybe pre-sorting your incoming data into relevant categories before you even think to ask. It's about anticipating needs based on analyzing millions of data points instantly.
Okay, that leads naturally into the human-machine interface part. Specifically, they mentioned OChat and OPAL for conversational intelligence.
Right. These interfaces are said to use sophisticated natural language processing, or NLP. The goal here is apparently to move way beyond those clunky command response chatbots we're all tired of.
We've all been there.
Yeah. The aim is to facilitate human-like conversations, that's the quote, and create personalized digital companionships. So the NLP engine needs to understand not just words, but intent, context, maybe even sentiment, to make the interaction feel natural and genuinely helpful, not just transactional.
Okay, now here's a claim that sounds, well, incredibly ambitious, almost science fiction. It requires some serious scrutiny. Self-healing code. The source material seems to imply this is a truly revolutionary capability, like it fundamentally changes how software maintenance works.
This is probably the highest technical claim related to adaptive intelligence in the whole package, yeah?
Think about traditional software development. It relies on human-driven cycles, right?
Yeah.
A bug gets reported, developers write a patch, it gets tested, then deployed.
And that whole process means downtime, delays. Exactly. The source claims that their AI actively monitors the system's own operational code. It identifies bugs, performance anomalies, inefficiencies, whatever, in real time.
Okay, identifies them. But then what? Does it just flag the issue for a human developer, or does it actually fix it?
The claim is that it autonomously resolves many of them, instantly. So the AI isn't just spotting the problem, it's dynamically rewriting or adjusting the code on the fly to maintain operational integrity.
Without human intervention.
For many types of issues, yes, that's the implication. It would drastically reduce downtime and boost reliability if it works as described. It suggests the system is its own perpetual IT department, constantly tuning and optimizing its own health.
That really does move beyond basic automation into something.
Yeah, almost biological, the way they describe it evolving. Okay, and finally, within this AI pillar, the AI feeds back into the commercial side with smart recommendations. Right. This is maybe the most user-facing application of that predictive engine we talked about. The machine learning is constantly working to suggest relevant products in OShop, maybe connect potential business partners it identifies, or push relevant content or tools within the platform.
So trying to make the ecosystem more efficient for users.
Exactly. By improving the quality and relevance of those recommendations, the system aims to increase efficiency for the founders using it and just generally improve the ecosystem's overall flow of transactions and information. The key takeaway for this whole section is crucial. This is positioned not just as automation, but as truly adaptive intelligence.
And that foundation of intelligence leads perfectly into the next pillar, pillar 3, automation. The power of effortless productivity. The philosophy here is almost a direct challenge to how we normally think about work. Why work hard when your system can think harder?
Right. Automation here is framed as the practical application of that AI intellect we just discussed. It's the technical backbone that allows complex multi-step business processes to just happen seamlessly, instantly in the background.
Taking the load off the user.
Exactly. Eliminating human delay, freeing users from repetitive mechanical tasks so they can focus on higher level things.
Okay, so let's make that concrete. If you're a founder running an international business using this ecosystem, how are those complex end-to-end processes coordinated? Things involving, say, OShop, OMail, and OWallet. How does that happen without a human manually managing every single step?
Through what they call smart workflow engines. Because the whole on-passive system is described as fundamentally unified, these engines can coordinate everything automatically.
Like what, specifically?
Like from the initial customer onboarding process, triggering automated follow-up communications through OMail, all the way through to processing the payment instantly via OWallet and confirming it. These complex chains of events are handled automatically, instantly, without needing manual checks or interventions across different products.
Now, for data integrity, making sure everything stays consistent across the board, that's paired with event-based triggers.
Exactly. An event happens, let's say a user registers for a webinar through OConnect. That action automatically triggers a predefined chain of system responses.
Such as?
A confirmation email goes out via OMail. The analytics dashboards and OTracker get updated instantly. The central database is refreshed. Everything stays perfectly synchronized across all systems in real time. And crucially, this relies on what the docs call multi-layer synchronization, meaning whether you're looking at data in OShop or OWallet or OTracker, it's all reflecting the same single source of truth instantly updated across the whole environment. No more data silos, no repeating information, no inconsistencies.
Okay, and the big payoff for the founders using this system, the benefit of all this coordination, is highlighted through AI-driven marketing, using tools like OPost and OTracker.
This is where automation really delivers what they call the gift of time. The AI takes over the grunt work, the mechanics of marketing.
Like what?
Automating campaign management, scheduling social media posts across different platforms via OPost, continually analyzing and optimizing traffic funnels using data from OTracker. By taking over these operational burdens, the ultimate goal is to create a business that essentially runs itself on the back end.
Freeing up the human.
Right, allowing the founder, the user, to focus purely on strategy, on vision, rather than getting bogged down in the day-to-day mechanics.
Okay, let's move on to Pillar 4. Security, the invisible fortress. This is obviously critical. In an ecosystem designed to handle global transactions, sensitive communications.
Yeah.
Security can't be an afterthought.
Absolutely not. The sources describe it as the foundation, not just a layer added on top. They use the term military-grade cybersecurity. That's a very strong claim, a high standard to set.
It really is.
And the technical mechanisms described need to support that claim. Ash Mufareh is cited in the materials as prioritizing security above almost everything else because, well, a failure here undermines the entire value proposition.
Makes sense.
So the system is apparently fortified with several advanced layers designed to protect both the platform itself and the integrity of its users' data and funds.
Okay, where do we start? Identity verification seems paramount, especially for a global financial ecosystem. The source mentions a revolutionary O-Verify OKYC system. OKYC. Online. Know your customer right.
Correct.
How is this AI-driven system supposedly different from the standard KYC processes we deal with, say, when opening a bank account? Those could be pretty slow and clunky.
That's the point they make. Standard KYC is often slow, manual, reactive. O-Verify is designed as an immediate, AI-driven verification system. It uses machine learning algorithms to verify identity documents, perhaps cross-reference data points, basically ensuring that only verified real human users, not bots, not fraudulent accounts, can access sensitive services like OWallet or handle financial transactions.
So it's faster and automated.
And presumably more accurate, weeding out bad actors before they even gain entry. That level of immediate automated verification is presented as critical for building and maintaining trust in a system intended for global commerce.
Okay. And then to protect the integrity of the financial records themselves, like commission payouts, transactions, the system claims to use blockchain integration. Now, blockchain gets thrown around a lot. How is it specifically implemented here, according to the sources?
It's reportedly used to secure the records of transactions, commission calculations, and fund movements within the ecosystem. The idea is to create a transparent, yet secure, and crucially immutable record of all financial events.
Immutable meaning?
Meaning, once a transaction is recorded on the blockchain ledger, it cannot be altered or deleted retroactively. The documentation claims this makes fraud or data tampering related to commissions and payments impossible.
A very strong word, impossible.
It is. The decentralized security of the blockchain essentially acts as a permanent, encrypted public witness to every critical financial flow within the on-passive world.
Okay, so we have identity verification and immutable records. What about active defense? Protecting against ongoing threats? That relies on the AI again, doesn't it?
It does. That's the AI intrusion detection system. Traditional firewalls, they're mostly reactive, right? They block known threats based on predefined rules or signatures.
Right.
This AI system, leveraging machine learning, is described differently. It monitors real-time traffic patterns and complex user behavior across the entire network. It's looking for anomalies, deviations from normal activity.
Like what sort of deviations?
like a user suddenly trying to access data they've never touched before, or maybe a login attempt from a very unusual geographic location, followed by rapid high-frequency activity. Things that suggest a potential compromise or attack in progress.
And it detects these before they cause damage.
That's the claim. It predicts and detects threats before they fully materialize into a breach, and then presumably takes action to block or isolate the threat. It's presented as a truly self-defending architecture.
And finally, for basic privacy in communications and transactions.
There's the expected but absolutely critical end-to-end encryption. Whether it's sensitive financial details being entered into O-Wallet or private video conversations happening in O-Connect, the entire data flow is supposedly funneled through encrypted channels from sender to receiver.
So putting it all together.
The system is described as self-defending. The AI acts as the guard, the gatekeeper, and the guardian angel, all rolled into one, protecting sensitive data and funds.
Okay, that security foundation is crucial. Now, moving seamlessly from fortification, let's look at Pillar 6. Interconnectivity 1 login. Infinite possibilities. Because as we know, security and speed don't mean much if you, the user, have to constantly jump between 10 different programs and logins.
Exactly. And the key technical advantage claimed here is that seamless synergy. The structure is deliberately designed to eliminate the silo effect you see with many business software suites,
where each app feels separate.
Right. Here, every product, OMail, OConnect, OShop, OTracker, OWallet, OVerify, they're all designed to operate as parts of a single cohesive whole. They share the same underlying data structure, the same communication protocols. They're built to talk to each other fluently.
And the technical mechanism that makes this easy for the user is single sign-on, SSO.
SSO is the user-facing part, yes. It's the technical backbone that allows you to access the entire suite of tools with just one secure login. That obviously removes the friction and the security risk of managing dozens of different passwords.
Definitely a plus.
But maybe even more importantly, the sources emphasize the data flow advantage. Because it's a unified system, data doesn't need to be manually copied, exported, imported, or re-entered between applications. It moves freely but securely thanks to the encryption and access controls between applications. This automatically eliminates redundancy, reduces errors, and vastly enhances the accuracy of the data everyone is working with.
Okay, let's make this concrete. The source material gives a detailed synergy example. Walking through that might really illustrate this idea of total digital synergy.
Yeah, it's a good one. Imagine you're hosting an important business webinar using OConnect.
Okay.
Within that single OConnect session, because the system is integrated, you can supposedly instantaneously process sales, maybe for a product you're launching, and receive payments directly through the integrated OWallet function. No sending people off to a separate payment page.
Right there in the webinar interface.
That's the idea. And simultaneously, OTracker is automatically logging every attendee's engagement level. Who stayed till the end? Who left early? What links did they click on during the presentation? All that behavioral data is captured.
Without you doing anything manually.
Correct. And then the automation engine we talked about earlier can automatically trigger follow-up actions based on that data, maybe sending targeted promotions via OMail to those who showed high engagement, or automatically distributing the webinar recording via OPost to everyone who registered.
And all of this happens
immediately, driven by the AI, all within that single unified environment. You, the host, didn't have to log into 3 or 4 separate pieces of software to make it all happen.
That integration is the core value proposition then, isn't it?
Yeah.
If it works like that. It saves time, boosts efficiency by cutting out manual data transfer, and ultimately should reduce operational costs. That makes the claim of total digital synergy feel much more tangible. It's about a flawless automated workflow.
Okay, moving on. We transition now to Pillar 7, Communication Intelligence, the voice of the ecosystem.
Right. And here the focus shifts. Communication isn't just about, transferring data bits back and forth. It's positioned as an adaptive, frictionless experience, especially when using tools like OConnect for meetings or the Opal Assistant.
Exactly. The focus seems to be on making sure the technology itself never becomes a barrier to clear, effective human interaction, regardless of where people are geographically or what technical limitations they might face.
Which means overcoming some common hurdles.
Definitely. Things like language barriers, poor audio quality, low bandwidth. The system has to address those to be truly global and user-friendly.
Okay, let's start with the obvious one for a global platform.
Yeah.
Language. The source mentions real-time translation engines.
This is pretty critical for that global inclusivity goal. The sources describe advanced translation engines integrated directly into OConnect, for example. The idea is to provide seamless, real-time communication between participants who might be speaking different languages during a live call or meeting.
Not just text translation, but spoken translation.
That seems to be the implication for live interactions, yes. And the claim is that this technology doesn't just translate words literally, it attempts to capture intent and nuance, bridging cultural and linguistic gaps instantly. That's essential if the system is truly meant to operate without borders.
Okay. What about the technical quality issues that plague so many online meetings? Bad microphones, background noise.
Right, the bane of virtual calls. To tackle that, they talk about AI voice enhancement.
AI again.
Yes. This is described as a sophisticated AI application designed to clean up audio on the fly. It autocorrects sound clarity, dynamically adjusts equalization for different voices, and actively identifies and removes background voice.
Like a dog barking or a coffee shop chatter.
Exactly. The goal is to deliver professional-grade audio for everyone on the call, regardless of their individual microphone quality or how noisy their environment is.
That would certainly improve the experience.
Yeah.
Now, beyond just audio, the source mentions some advanced features aimed at deepening the sense of presence and engagement. Things like gesture recognition.
Yeah. This is interesting. Gesture recognition is apparently designed to bring some of the nonverbal subtleties of in-person communication into the virtual space.
How so?
It supposedly uses the camera feed to detect visual cues, maybe a nod of agreement, a thumbs up, or someone raising their hand to speak, and translates those into signals within the virtual meeting. The idea is to create a more natural, responsive, and engaging virtual environment.
And maybe the most practical feature for global accessibility, especially in regions with less robust internet. You mentioned data compression algorithms.
Yes, this might be less flashy, but it's fundamentally important. Why? Because these algorithms are the technical key to delivering high-definition audio and video quality, even for users who are on relatively low bandwidth connections.
Right, because not everyone has fiber optic internet.
Exactly. In many parts of the world, connectivity is still a major challenge. If your platform requires massive bandwidth just to function properly, you immediately exclude a huge portion of your potential global user base.
So the compression makes it work smoothly even on weaker connections.
That's the goal. By efficiently compressing and transmitting the audio and video data, the system aims to ensure that distance or limited local infrastructure never becomes a barrier to having a high-quality connection and interaction.
Okay, that robust handling of communication data leads us nicely into the next pillar, Pillar 8, intelligent data management, the ecosystem that thinks. Data is everything in modern business, we know that. But the big challenge is often moving from just having tons of data chaos to actually getting clear, usable insights from it. And the claim here is that AI handles this orchestration.
Right. For the founder, for the user, this is meant to translate into access to actionable insights without having to do the heavy lifting of manual data compilation, analysis, and interpretation.
How does that work in practice?
One way is through predictive analytics dashboards. These aren't just dashboards showing you what happened last month. They leverage machine learning, analyzing trends and patterns in your data to provide real-time insights into future trends, predictive customer behaviors, potential performance issues.
So looking forward, not just backward.
Exactly. Insights that you can supposedly use immediately for strategic decision-making, rather than just reporting historical facts.
And getting these insights doesn't require manually running reports each time. They mention automated reports.
Correct. The system is designed to generate necessary reports dynamically, in real time, often without needing any human input. This is meant to free up huge amounts of time that founders or their teams would otherwise spend just compiling spreadsheets or trying to validate figures from different sources. The system does the interpretation work.
Okay. And what about keeping the data itself clean and reliable? On the system maintenance side, two features caught my eye: data harmonization and self-cleaning databases.
Yeah, these are crucial for back-end integrity. Data harmonization is the process that ensures all the data flowing in from the various on-passive apps, OConnect usage, OShop sales, OWallet transactions, OTracker analytics is integrated into a single, unified view of the ecosystem.
So no conflicting data silos.
Precisely. It ensures every part of the system and every report generated is working from the same consistent, up-to-date truth. And then you have the self-cleaning databases.
Which sounds intriguing.
It utilizes the AI again, this time to constantly scan the databases, detect, quarantine, and potentially remove data that's redundant, obsolete, duplicated, or corrupted. It's about maintaining data hygiene automatically, optimizing storage efficiency,